Greetings, I'm Dev the developer.
And I'm Glitch.
Today, we're starting a payroll management system, and the first thing we're going to do is write ourselves into a problem. A design problem that you've probably felt before without having a name for it. Once we felt it, C# is going to hand us the solution, and it's going to change how you think about designing classes going forward. So, here's the setup. We need to model employees in a payroll system. There are hourly employees and salaried employees. They're different because the way you calculate their pay is different. So, the natural thing is to write two separate classes.
Yeah, that makes sense. Hourly employee for hourly workers and salaried employee for the salaried ones. Let me start writing those.
All right, stop. Look there. What did you notice?
They both have ID and name written out twice.
And that's two classes. What if we also add hourly employees who earned a shift differential, or commission employees, contractors? Every single one of them needs an ID and a name.
I'd be writing ID and name in every single class, every time.
And if someone later decides the ID assignment logic needs to change, how many places do you fix it?
Every class one at a time, and if I miss one.
You've got a payroll system where some employees get IDs assigned one way and some employees get them assigned another way. And nobody notices until it breaks something important.
That's bad. The ID logic is one thing. It should live in one place.
It should. And that's exactly what inheritance is for. Before we fix the payroll code, let me show you the mechanics with something simpler so the concept is clear. Think about animals. A dog has a name. A cat has a name. They both breathe. If you wrote a class for every kind of animal from scratch, you'd be writing name and breathe over and over again. What you want to say is there is an animal and a dog is one of those.
And if dog is one of those, it should automatically have whatever animal has.
Exactly. Write the animal class first. Now, here's how you make dog inherit from it.
That's it, just the colon and animal.
That's it. That colon means dog extends animal or dog inherits from animal. Both phrases mean the same thing. And now a dog has everything animal has without rewriting any of it.
So name is declared on animal, but I can use it inside fetch in dog because dog is an animal.
Let's prove it.
OOH breathe is from animal, fetch is from dog, Rex can call both. It didn't need to declare breathe anywhere.
Animal is called the base class. Sometimes you'll hear parent class or superclass. They all mean the same thing. Dog is the derived class, also called child class or subclass. The vocabulary is inconsistent across languages and textbooks, but the concept is the same everywhere.
So when should you use inheritance? Is there a rule?
There's a test. Say the relationship out loud. Dog is a animal. Does that sentence make sense?
Yeah, a dog is definitely an animal.
Flip it. Animal is a dog.
No, not every animal is a dog.
Right. Inheritance only goes one direction. The derived class is a more specific version of the base. Now, try a wrong pairing. Say we had a leash class. Leash is an animal.
No, a leash isn't an animal. A leash belongs to a dog. That's a completely different kind of relationship.
And that's your gut check. If the is a sentence sounds wrong, inheritance is probably the wrong tool. Apply that test before you add the colon. Now, let's take this back to the payroll system. Hourly employee is a employee. Salaried employee is a employee. Both of those hold. So let's write the employee base class and move the shared data there.
And now the derived classes just use the colon syntax. ID and name are gone from both subclasses, they live once. If the ID logic ever changes, I fix it in employee and it updates everywhere.
That's the shape of it, but we're missing constructors, and that's where things get interesting. Let me add a constructor to employee that takes a name.
Okay, and I'll add a constructor to HourlyEmployee too. That's a weird error. My constructor takes a name. What does it mean there's no argument for it?
Read it carefully. Whose constructor is it complaining about?
It says employee.employee open paren string close paren, so employee's constructor.
Right, not your constructor, the base constructor.
But I didn't call employee's constructor. I'm writing HourlyEmployee's constructor.
Are you sure you're not calling it?
I mean, I didn't write a call to it. Oh wait, when C# creates an HourlyEmployee, it also has to set up the employee part. So it tries to call employee's constructor automatically.
And?
An employee only has a constructor that requires a name. C# has no argument to give it, so it errors.
Right. The base class portion has to be initialized before the derived class portion. C# enforces that. The base class always goes first.
Okay, so I just need to give employee's constructor the name, but it's not my constructor. I can't edit what it runs internally. What if I add a no argument constructor to employee, then C# can call that one automatically and I don't have to pass anything?
You could try that. What would happen?
Okay, it compiles now. Let me test it. It printed nothing. Alice.name is blank.
So the empty constructor made the error go away without actually fixing the problem.
Because the empty constructor runs and nobody ever sets name, the parameterized employee constructor with the name assignment doesn't get called at all. The name just gets lost.
This is a very common trap. The compiler stops complaining, so it feels fixed, but the data is gone. What you actually need is a way to pass a name from your constructor into the specific employee constructor that handles it. And there's a syntax for that.
Okay, so remove the empty constructor.
Remove the empty constructor, then on HourlyEmployee's constructor, after the closing parentheses, add a colon followed by base and the argument you want to pass.
So the colon base with the name argument explicitly calls employee's constructor. Employee runs first, sets name, then HourlyEmployee's body runs and sets hourly rate.
In that exact order. Base always before derived. Think of it like building a house. The foundation goes down before the walls go up.
And the colon before base here is different from the colon in the class declaration, right? The one in the class header establishes the inheritance relationship. The one in the constructor is constructor chaining. Same character, two different purposes.
Different syntax, same direction. Both mean pass something up to the parent. The class level colon establishes a relationship. The constructor level colon specifies how the base class portion gets initialized.
There she is, name is set correctly.
Now, let's actually finish the employee class. We want that auto-incrementing ID, and there's a detail about where it should live and what modifier it should get.
The next ID field is private static. Static because it's shared across all instances, the same counter for every employee we create. Private because nothing outside employee should ever touch it.
And the ID property that gets assigned from it is public, so the payroll output can display it. Now, here's a question. What if a derived class needed to access something from the base class directly? Something internal, but you still do not want outside code touching it.
If it's private, derived classes can't see it. If it's public, everyone can. Those have been our only two options.
Until now. There's a third modifier, protected.
Oh right, we've seen this mentioned, but never actually used it.
Protected means the class itself and any class that inherits from it can see the member. But code outside of the family cannot. It's private to the outside world and visible to descendants.
Private for families.
That's a good way to put it. You won't always need it. A well-designed base class can often give derived classes what they need through properties. But when a derived class genuinely needs direct access to something the base class holds, and you do not want to make it fully public, protected is the right modifier. Let's put it to use.
So HourlyEmployee can call format header from inside its own methods. But if I try to call format header on an HourlyEmployee object from outside the class hierarchy,
the compiler refuses. It's not accessible there. Protected draws a boundary around the family.
That's actually useful, like it's specifically for the my subclasses need this, but nobody else does case.
Exactly that case. Now, let's build out both subclasses properly and add a calculate pay method, because that's where this whole hierarchy starts earning its keep.
Hold on, virtual, that's new.
We're going to cover virtual and override properly in the next video. Short version for now. Virtual on a method means derived classes are allowed to replace or extend it. That's all you really need to know right now.
Okay, I'll accept that for the moment.
Now, add calculate pay to HourlyEmployee as well. 40 hours at the hourly rate. Good. Now, here's where the base.calculatePay becomes genuinely useful. Say we need a manager. A manager is a salaried employee who also earns a bonus. How would you design that?
Okay, so manager is a salaried employee, which is a employee. The ISA chain holds all the way up.
Write it up.
Override is new too.
Same deal, next video. For now, override means I'm providing a replacement for the base version. The important thing here is what is happening inside the method body.
Base.calculatePay runs SalariedEmployee's version, which gives the bi-weekly salary. Then I add the bonus on top.
Where does the salary calculation logic live?
In SalariedEmployee, just once.
And if someone changes how bi-weekly pay is calculated for all salary employees?
One change in SalariedEmployee, manager picks it up automatically because it calls base.calculatePay. There's no duplicated logic. So base.MethodName is the same idea as inheritance for properties and fields. Write it once, build on it. If I had recalculated the salary inside manager.calculatePay, I'd be back to the duplication problem we started with, just in a different place.
Exactly right. The principle is the same whether you're talking about data or behavior. The base class defines it once. Derived classes either use as is or extend it with base.MethodName. They do not recalculate or redefine what the parent already owns. Let's run all three of them and see the hierarchy in action.
3 employees, 3 IDs assigned automatically, 3 different pay calculations, and the salary logic only lives in one place. Actually, the ISA chain is interesting to think about. Manager is a salaried employee is a employee, so manager has everything that salaried employee has, which has everything employee has. And since employee is the base of the whole structure, if you were designing a system where a derived class inherits authority from every class above it in the chain, you could theoretically construct a hierarchy where the most derived class concentrates all the access from every level above it. Like an authority structure that grants cumulative permissions through the chain, every level grants the one below it, and the bottom level accumulates all of it.
I'm going to pretend I didn't hear most of that.
I meant for modeling payroll tiers, compensation authority. That's the use case I had in mind.
Moving on. Let's talk about the two uses of base because they look similar and mean different things. What's the distinction you would draw?
Okay, so the colon base part in the constructor signature calls the base class constructor. That runs before my constructor body. That's constructor chaining. And base.CalculatePay inside a method body calls the base class's version of that method. That runs when I call it, wherever I put it.
Two different uses of the base keyword, both mean go up to the parent. One applies at construction time, one applies at method call time. They don't interfere with each other.
And forgetting the colon base when the base class only has a parameterized constructor gives you that compiler error we hit earlier.
Which is why it's worth understanding, not just memorizing the syntax. When you see that error, you know what it's telling you. Last thing to round this out. You started this series knowing public and private. Public is visible to everyone. Private is visible only inside the class that declared it. Protected sits between them. It's visible inside the class and anything that inherits from it, but invisible to the outside code. It's the modifier that only makes sense once inheritance exists. Now it does.
Private for families.
Private for families. The next video gets into virtual and override properly, what that pair actually does, and what becomes possible once a base type reference can hold any derived object. That's where this gets genuinely interesting.
I'm looking forward to that one.
The pattern you've seen here shows up everywhere once you start looking for it. One base class holding what's common, derived classes adding what's specific, constructor chaining passing initialization upward, and base.MethodName letting derived classes build on top of the parent's behavior instead of duplicating it. The best way to lock that in is to build it yourself. Start with a vehicle base class with a make and a model. Add a car subclass with a door count and a truck with a payload capacity. Add a describe method to each. Call base.describe from inside the derived versions. See the pattern click into place with your own hands. Don't just watch it, do it.